Hello everyone. In this video, we will continue our study of topic D.3 cosmology, and in particular, we will begin to examine Hubble's law, the concept of redshift, and how it applies to the Big Bang model. So, to understand redshift, we need to back up a little bit and explain just a single application of the concept of the Doppler effect. So the Doppler effect was traditionally articulated and measured with respect to sound. The familiar effect of, say, a car siren as it comes past you, that sort of whew effect right there, has to do with the fact that waves from a moving object or detected by a moving object experience a shift in frequency. And that shift in frequency for sound in a frequency corresponds to pitch, but that shift of frequency is related to the velocity. And for light, for reasons you would need to be careful of when you derive, but for light, we see a similar effect. Strictly speaking, not all red shifts and blue shifts are Doppler effect oriented, but redshift and blue shift are words that describe the change in frequency due to motion. And the higher the velocity, the bigger the change in frequency, which is captured in this equation right here. And in particular, if an object is moving towards you, that shift in frequency is positive. It makes the frequency higher. As a result, you get what's called a blue shift, where all of the lines that you might see in a spectrum are shifted in the blue direction. Notice that if these are the absorption lines in something you're observing and they're at rest, you would see those exact same lines shifted to the blue. So we really rely on absorption and emission spectra to detect this in light and astrophysics. If those objects are moving away from you, delta F is negative, and you get what's called redshift, which was referred to at the end of the last video. And that means all the lines that you would normally expect to see at particular locations are shifted in the red direction. Notice it doesn't mean the lines themselves are either blue nor red. It just refers to which direction that frequency shift is in. And so we use the spectra from the stars with their absorption lines to detect whether a star or a galaxy is moving towards or away from us. We can go find those very recognizable patterns in the lines if you're looking for hydrogen or helium. They're quite visible, fairly straightforward to measure. And if they're in the wrong place, then we know that there is some radial motion. Notice I say radial motion because we can't detect any velocity tangential to us. That means we can only detect velocity towards away from us. If we're over here and the object is moving this way, we wouldn't be able to detect that velocity. So that's the Doppler effect for light and for astrophysics.